This is our third video on chapter 2, and this is on doing arithmetic. So the good news is most of what we're going to do with arithmetic is going to be the same as it is in Python. Okay, but there are some differences kind of below the surface that we'll have to talk about. So let's start by looking at what the operators themselves look like. Okay, so just as in Python, we have the plus symbol for addition. Okay, so if we have it over here, the example, we have an integer a equal 5, integer b equal 2. If we say int x is equal to a plus b, 5 plus 2 is 7. And if we print it out, so the value of x is now 7. Of course, that's not a print statement, but we could. Okay. The same thing, it's minus for subtraction. It's the asterisk or star for multiplication. It's the slash for division. Again, the division assumes that the denominator is not equal to 0. If so, it's going to throw an error. Okay. Note that if you have two integers here, okay, we've got a 5 and a 2, and we have another integer for uh, the s here, then the 5 slash 2 is 2 since s is an integer. Okay. If we had floats, that would be 2.5. Okay. So sometimes that gets difficult. Okay. Um, we also have the modulo operator, the modulus operator, or mod. Okay. And we're going to use that more than you would imagine. Surprised we don't teach that more to kids in high school and earlier, because modulus is pretty important. It basically is going to return the remainder. Okay. So if we have a 5 mod 2, okay, it's going to take 5 divided by 2, which is 2, and what's left over. Okay. That's 2 times 2 is 4. 5 minus 4 is 1. So the remainder is 1. Okay. So again, it turns out to be more helpful than we sometimes think. As far as if we have a line or an equation with multiple um, operators going on at the same time, we have to know what order to do them in. And this is exactly like it is in math, and it's exactly like it is in Python, in that we can use the acronym PEMDAS, okay, PEMDAS. So that's the order it goes in. So the highest priority is parentheses. If things are in parentheses, they're done before anything else. Okay. Next in order is exponentiation, if you're raising something to a power. Okay. Next is multiplication and division. It's not multiplication then division. Multiplication, division are at the same level. And then finally, addition and subtraction are also at the same level. Okay. So if they're on the same level, you would do them from left to right. Okay. So let's take a look at this in code. Okay, so let me now share screen here. Okay, so I'm logged in to the server already. Um, I didn't do that for this video and probably should have, but I didn't. And I did a PWD, as you can see, and I'm in the correct directory. So I'm in the my working directory. Okay, which is good. Okay, so now to do some basic examples in code. Again, we're going to Emacs. We're going to call this math.cpp. Again, we have to do or include IOStream. We have to use our using namespace standard. We do our int main. We do our return 0 and close the curly brackets. Okay. So again, these work pretty normally. Okay. And then if I want to say, like my examples before, int x is equal to 5. Let's do it different. Let's combine what we did in the last video. So we have an integers, let's say x and y. I could do something with the following. I could say cout, enter an integer. Again, at this point, we have to trust that they're actually entering an integer. Cnx. I could do a cout to say enter another integer. Don't forget that space. Cny. I could have also have done two variables, with a space between them if you wanted to. Okay. And then let's say I do want to track this. Okay, so I could have S for the sum. I could say that S is equal to X plus Y. Okay. Then I could see out the sum of, got to put a space there. X is our first value. Okay, then I have to put a space and space. Y is our second value. Space equals space S. And then I can end my line. Okay. And we can see you sometimes have to play around with the output lines to make sure they look right. Okay. So let's see if I did this right. So we have G++ dash O dash O math.exe, the math.cpp. Okay. Doesn't like something. Okay. It doesn't like, let's find the first instance of an error. I'm glad I finally made one, but boy, that looks like a combo. It looks like I've got my operators the wrong direction. Let's see. Okay. So this C out, yeah, it's this one. See, that one goes that way. Okay. The C ins go toward the variable. The C outs go toward the C out. Let's see if that fixes it. Okay. Yep, now we're good. That's all it took. Okay. So now I can do the dot slash on the math.exe, enter an integer, 3 and 4, and it prints the sum of 3 and 4 is 7. Okay. I kind of mixed on the output. So instead of that, I could just say instead the X value and put a plus in here. I think that would look better. Plus Y equals S. See if that improves things. We'll do 5 and 2. 5 plus 2 is equal 7. Okay. So that looks better. Okay. So that's in general how things are going to work. Okay. Note that because of the implicit typecasting we talked about before, you can do mixed things. Okay. So let's take an example of that. And we can also directly output the results. Okay. So this time, let's say instead of allowing input, we're gonna do this all differently. We're just gonna totally wipe it out. Okay. So let's say we have an int x that's equal to 9. Okay. Then we have a float y that's equal to 2.5, let's say. Okay. Then I can see out directly the result of x plus y and see what we get. Okay. So we could do things with floats and ints usually because it's not going to be a big deal. Okay, I'm going to compile it, going to run it, and you see that's 11.5. Okay, so the answer here, what it had to do, this goes back to our last video, it had to do an implicit conversion of this 9 to a 9.0. Okay, in order to be able to add it to the float. Okay. So as far as differences go from Python, the big difference is going to be that if we get past that 2 billion that we talked about in the previous video, about the range of an integer, then we're going to wrap around to the negative numbers and it's going to be a problem. Okay. And in Python, Python doesn't limit how big your numbers can be. Your numbers can be as big as your computer memory allows. So numbers can get really gigantic in Python. Okay. If you need numbers that big in C++, you have to move from a regular integer to a long integer, and sometimes you can do a long integer, which just put aside more space in memory and allow you to have larger numbers. Okay. So that's one thing that we have to worry about. Okay. In particular, if you do something like a factorial is going to be, a number times 1 minus that number all the way down. So 5 factorial is 5 times 4 times 3 times 2 times 1. Those numbers get really big really quick. Okay. So if you have a Python program, did I actually do that? Maybe I did. Let's see if there's a Python. That's just the test.p thought. I think I just thought about it, but didn't actually do it. Yeah, so if you write a factorial program on in Python, you could do factorial to some gigantic number and you'd be fine. Okay. Whereas if you're in C++ with a regular integer, any number bigger than 20 is going to give us that overflow and we get the weird errors. Okay. So that's something we have to worry about when we're in Python. Okay. So we can look at this idea of the order of operations and something that comes up a lot. Okay. You'll see online people say, what's the answer to this equation? And they'll have a bunch of different things together. Okay. And people will fight about what it is and what it's not. Okay. But math is math, and there's only one answer. And if we follow the order of operations, we'll know what to do here. So let's say, and this is in the book, let's say we're going to do something like we want to do 6 divided by 2 times 1 plus 2. Okay. So that's kind of what we're doing here. So the question comes up with folks. So to solve this with the PEMDAS, right? The first thing is parentheses. So we take the 2 plus or the 1 plus 2 and make it a 3. Okay. And people want to do a 3 times 2 first. And that's incorrect. Okay. Because at this point, we've reduced all the parentheses. We look for exponentiation. There aren't any. Okay. So we have a multiplication and a division. So we do them in order. So 6 divided by 2 is 3. 3 times 3 is 9. And 9 should be the correct answer. Okay. So if I were to code this, okay, I could do the following. I could say that int x is equal to um, 2, no, 6 was the first one. Int x equal to 6, int y is equal to 2, and int z is equal to 1. Those are the 3 numbers that we had. Okay. So I could say int something else, n is equal to. Well, I wouldn't need all this. I can just go strictly to the n. Let's do it that way. What am I doing? I could say n. I just do it here. I could do this 6/2 times 1 plus 2. That would work. Okay. You can space these operators out if you want, but you don't have to. That's just for looks. Okay. If I do that and do a C out on n, and compile it and run it, you see that it does give us the correct answer of 9. Okay. So that's an important thing for us to do. Okay. Is to make sure that we know how that's going to work. Okay. One of the other problems that the book talks about that's a little difficult to do on the video, it's converting formulas that you may find into something like a math formula into a formula we could use in our programs. Okay. So that's in section 6.4 of the book, and it's worth going through that example, just so you know. Okay. In general, the trick is kind of if you have a whole bunch of stuff divided by a whole bunch of other stuff, you'll put parentheses around the numerator and the denominator to kind of keep them together. Okay. And I think that's the most straightforward way that we can do things. Okay. And there are a couple of examples there in the book that you can use, which I think will be helpful in making sure you understand this. Okay. So let's do one example of a program that the book talks about for sure. Um, let's do a calculation of miles per hour. Okay. So we're going to use some of the new skills we've developed. So we're going to start with our include, the IO stream, our using namespace standard. Okay. Our int main, our return 0. All your programs should have comments. I'm going to put some comments. I'm going to put the miles per hour calculator. I'm going to put my name as the programmer. Well, so I'm going to ask user for miles driven and gallons used. I'm going to calculate miles per gallon. I named this MPH, which is not what it is. It should be MPG. We can fix that. Uh, Calculate equal to the miles divided by the gallons. Okay. So we're going to start here by we're going to declare our variables. Okay. Now for miles and for gallons, we could use integers, but that's probably not very realistic. So let's go ahead and use doubles. So I'm going to have a double miles. I'm going to ask the user for it right away, so I don't have to worry about it, this value being something random. So I'm not going to initialize it. Okay, I'm going to have a double miles and gallons. Okay, I'm now going to ask user for information. Notice I'm using comments to kind of scaffold my program here, because then what I'm going to do to finish this thought here, I'm going to calculate miles per gallon. And I'm going to print or output the results. Okay. So to ask the user for information, I'm going to do a cout. I'm going to enter miles driven. Okay. I'm going to cin the miles. That's going to be as a double. I'm going to cout, enter gallons of gas used. Need a space there so it looks right. Cin gallons. Okay. I needed another variable up here, so I can go ahead and add it. It's pretty common you add it. Miles per gallon. I could add it right here, but I don't like that. I think it makes more sense to add them at the front. It wouldn't be wrong, but it wouldn't be as right, and you could lose a point for that. Because style, if you look on the syllabus, style is one of the things I'm going to be judging you on to some degree. Okay. So miles per gallon is going to be equal to miles slash gallons. Okay. And now I can print out your miles per gallon is space MPG indel. Okay. I didn't say this before on the input output file, input output video, but I should have. That when you see just MPG without any quotes, it's going to find a variable of that name and print out its value. Okay. So let's see if we got this correct or if I made any errors. Okay, that's a common problem. See what I just did? Because I wasn't paying attention. I just compiled my math program. I didn't compile my new program. Okay. First, our file name's wrong. So if we do an LL, we'll see that we have an mph.cpp. It should be mpg. I can use the mv command. It's just like copying that does a from to, but it doesn't you end up with one copy, not two. So if I can say mph.cpp is the from, I want to change it to mpg.cpp. Okay. Now if I list my files, I have an mpg. So now I can do my G++ on, and notice that on the screen, Warp has already figured out what I want. Okay. So I could just hit the right arrow key and it's done. Okay. So if you're using Warp, it's one of the advantages. It uses low-level artificial intelligence to anticipate. But it is what we wanted to do, so let's talk about it. You could also type in -o, we want the mpg.exe, and we want to be compiling the mpg.cpp. Okay. You do that, no error, so it looks okay. So I can do a /mpg.exe, enter the number of miles, 100, enter the gallons, 10, gives us 10 miles per gallon. Okay. And That's a little bit ugly. So let's think about how we can make that a little bit prettier. Okay. Let's go back into this. That's apparently the old name. So I have to go back with the new name. I'll just type it in again. Emma, find your home keys. Emacs mpg.cpp. Okay. So let's say before we do this, get a little fancier. We're going to see out mpg calculator. Okay. I'm going to put some, that should be inside of the quotes. Just putting in some minus signs and equal signs. Is that making it fancier? I don't know. Just trying to do something different. Okay. Do that. Okay. If I want to do another space there or another line down, okay, I can just do a C out end L. That would do a new line. Okay. And then we're entering this. Okay. I can put in, I think I can put in a slash T there, and it's going to tab that over for their response, which may look okay. And then I don't like the way that reads. So I'm going to say car efficiency is that, and then I'm going to do space MPG. Okay. I think that's going to look a little better. Let's see. So what I had before probably would have been a 9 out of 10. Hopefully this will be a 10 out of 10. Okay, looks a little bit better. Okay, so I drive 100 miles. I get 10 miles to the gallon. Got a problem there. See, because the inner gallons of gas used is too big, I'm gonna have to go back and add another tab on before the 100. Okay. So the 10 MPG looks better. So let's go back into our code here. And down here, I'm just going to do two tabs to make it line up. You could even, if you want to make it look a little better, you could do a tab there. You can go tab crazy. And at some point, it becomes a matter of personal preference on what you want to look like. Okay. Let's see if all those did any good or not. Okay, 100, 10. Yeah, we're off one on that one. But in general, I'm liking the looks. I'm not going to worry about fixing that. But you can, I do like that we've indented a little bit off of the left side for things, but I may be doing a little bit too much on the other tabs. Okay. So that's the idea behind doing arithmetic. So again, it's very much like Python, but we're going to have to worry at some point when we're entering numbers to make sure that they're actually the numbers we want. We are going to have to make sure that our answers are not going too far and doing an overflow of the integer and coming back around to negative numbers. Okay. So that's the end of chapter 2, which dealt with variables, um, and input and output and arithmetic. Okay. So we're getting some more building blocks for our code now. Okay. So the next two chapters are going to cover the basic control structures. The first is going to be selective execution, which an if, an else if. Okay. And then the next chapter will be on repetition with for loops and while loops. Okay.